Today we're taking a look at osmosis and tonicity, and the objective is to predict what's going to happen when cells are placed in different types of solutions. Okay, so just as a review of osmosis, okay, remember osmosis is a type of passive transport, okay, where it only moves water, and it uses a special protein to let water through, and here we have this protein that's here. That's because water a lot of water might not be able to squeeze through the phospholipids because of the tails. The tails are hydrophobic. They don't like water. So remember that water likes to move where there's a lot of water to where there's not a lot of water. And the cell doesn't need to use any energy to do this because they're moving with, the water molecules are moving with the flow or with the concentration gradient from high to low concentration. So in this picture we have a high concentration of water molecules on the inside of the cell, and there's a low concentration of water molecules outside, so that water wants to move through the protein, the aquaporin, to go outside of the cell. Now, let's take a look at situations where we have different types of solutions and what happens to the cell in terms of osmosis, how water is moving. So remember, in chemistry class, you looked at these terms. A solvent is a substance that would dissolve solutes. So like water can dissolve things like solutes. And what's a solute? It's a substance that can be dissolved. So think like, let's say, sugar or salt, okay? Now, we have these things in and out of our cells, and I'm going to represent these black circles as these solutes. They could be sugars, they could be salt. They're inside and outside of the cell. And these Mickey Mouse looking structures, they're the H2O. There are water molecules, okay? And when you put a solute with a solvent together, that's a solution. So let's take a look at this first solution, hypertonic solution. What if we put a cell in a hypertonic solution? Before we figure out what hypertonic means, let's break it down a little bit and look at the solutes. Okay, so where is there a high concentration of solutes, or where is there a lot of solutes? Well, if I were to take a look at the black dots, there are more black dots on the outside versus the inside. Okay, so there's a high concentration of solutes outside compared to inside where there's less. And I need you to go ahead and label where there's a high versus a low solute concentration. Now let's take a look at the water concentration. Okay, take a look at how much water there is outside compared to how many water molecules there is inside. Okay, and we can see that there's more water inside compared to outside. So I want you to go ahead and label where those concentrations are. So since there's inside, there's a lot of water, there's not as much solutes, not as much salt or sugar that's there on the inside. Versus the outside, there's a lot of solutes, so that means there's not a lot of water that's there. Now focusing on osmosis, okay, where's the water going to move? Is water going to go into the cell or out of the cell? And remember, water likes to move where there's a lot of water, so we're going to take a look at the water concentration. And there's a high concentration inside, and all that water wants to move out of the cell to reach equilibrium. Now, this happens when water leaves the cell, when the cell is in a hypertonic solution. And what does hypertonic mean? Hypertonic means it's just a solution where there's a lot of solutes there, but not a lot of water. And that causes all the water inside to go ahead and leave. So let's take a look at the picture that's here. Okay, and you're going to be drawing or writing a description of what's happening to the cell when it's placed into a hypertonic solution. So here, in a normal cell where it's not put in a hypertonic solution, water goes in, but also out at the same time. But when it's placed in a hypertonic solution, all that water leaves because there's a lot more water inside compared to outside, so more water will leave. And take a look at the animal cell. It gets all shriveled up. Okay, so this is what actually happens to your cells if it is in a hypertonic solution. Let's say like salt water. That's why you're not, if you're stranded on an island or something like that, and there's all this salt water there, it's not just fresh water, that water has salt in it. and it is a hypertonic solution. And if you drink it, then your cells will, the water in your cells will be drawn out because you're drinking that salt water. So what I want you to do is either draw this out or explain this in the in your notes, okay, of what happens when an animal cell is put in a hypertonic solution. We're also going to take a look at what happens when the cell is put into a hypertonic solution and it's a plant cell. So let's take a look at the picture that's here, okay? And like I said, you can either draw this out on your notes or explain it. Now, if it is a normal plant cell, I can see water going in and out at the same time. But here, if you take a look, all that green stuff, that's where the cytoplasm is, and it has water. If you see it, there's water in that cytoplasm, and it's leaving out when it's placed in a hypertonic solution. The other thing is, too, the vacuole, it got smaller because there's some water there, and then the water is leaving out. So all that cytoplasm is kind of like separating from the cell membrane and the cell wall because that water is leaving. Okay, we call that, when that happens, the cell has plasmolized. Okay, so you can either draw it or explain it in your notes that water is leaving the plant cell. And in this case, it's not going to shrivel up and shrink because it has an added layer of the cell wall to protect it from having to shrivel up. But water is leaving. You can see that from the change in the vacuole, it got smaller, and also the cytoplasm. It's kind of like there's not as much there. Okay. Now, let's take a look at a different situation. Oh, before we do that, let's look at a memory clue. So my memory clue for you is hyper skinny. So when I think of hyper, maybe I'm thinking of people who have lots of energy, and maybe they'll use that energy to be active and fit, and that might cause them to be skinny. So when you put a cell in a hypertonic solution, the cell's going to get skinny, or in other words, it might, shrivel up or have water be taken out of it. Now let's take a look at